Hello everyone, I'm Priyansh Patnagar, and in this video, in this playlist, we basically are going to develop a snake game using Java Swing library. Okay, so you guys might be familiar with the functionalities of the game, right? So if you have played it on previous Nokia phones, then you have to just do the control the snake using the key buttons, right? And you have to make it eat food, and by eating the food the snake size gets increased, and also the scores gets increased, and if it collides with the any obstacle on the board, right, then the game gets over and the score gets displayed, right? So we have developed a game using Java Swing similar to this. Okay, so let's have a quick demo, like what we are going to expect by the end of this playlist. Okay, so this is our particular application, and this moving thing of three dots is going to be our snake. Okay, so the red dot is basically indicating the head of the snake, and the green dots are basically indicating the body of the snake. Okay, and this apple on the board, it is going to be our foot of the snake. Okay, so when I make contact with the head of the snake, then it is going to eat the food. Okay, and its size gets increased by one dot, right? And I can control the snake with the arrow keys, right? I can control the snake with the arrow keys. Also, if I get collided with my own body, then the game gets over, okay, and the score is displayed. Also, if I get collided with the border also, then also it is going to make the game over and score gets displayed. Okay, so this is the complete demo of the project. Let's see what are the features that we need to implement. Okay, so what are the things that we need to implement to make this particular project? Okay, so to make this snake game, to make this snake game, we need to implement some of the features, right? The first one is going to be the basic UI. Okay, so we need to build the basic UI. So basic UI, why do I mean by basic UI? Basically, we need to implement the frames of the application, the content pane of the application, the dimensions of them, the color of background of them, right? Things like that. After that, I'm going to implement the graphics of the game. Okay, so what do I mean by graphics? We need to load the images, the red dot for the head, the green dot for the body, and the apple image for the food, right? And we basically need to draw these components on the position of them, right? So that is the graphics part. And after the graphics, we have the mechanics of the snake, right? So mechanics of the snake. What do you mean by mechanics of the snake? How the snake is going to move. If it is going in the particular direction, how it is going to move, right? How the coordinates are going to be changed, and how the snake is going to eat the food, right? Things like that. With that, I need to control the snake by arrow keys. Okay, so this is clear to you. We should be able to control the snake, otherwise there is no point. So we need to be able to control it by arrow keys, right? And after that, what we need to do is check for collisions with the border and the body, right? So check for collisions. And the last part is going to be the when the game gets over, then we need to display score and game over message, right? So these are all of the functionalities, these are all of the sections that we are going to go through, okay, in this playlist. And after completing all of the implementation part, then we will be able to make this particular game. Okay, so these are all the things that we need to develop in order to make this game. Okay, so that's all for this video. Thank you. Hello everyone, I'm Priyansh Patnagar, and in this video we are going to talk about what technologies that we are going to use for this particular project. Okay, So the only technology that we are going to use for making the snake game is Java Swing library. Okay. So what Java Swing library is? So Java Swing library is basically provides a set of lightweight components, right, to make window-based applications. Like, so what do I mean by a window-based application? It is going to create some windows. Okay. So it is going to make a window, and inside this window, I'm going to make an application. Okay, so it is going to create desktop applications, right? And inside this desktop application, I'm going to create the logic of that, right? So this is what Java Swing is basically used for, and there are particular classes that are defined in this particular package. Okay, so suppose if we go to, like you can see here, so what J button is, basically it creates a button on the application. What J checkbox is basically creates a checkbox on this, right? Combo box basically creates a drop down menu, and basically J file chooser basically creates a file picker for that, right? So J frame is basically used to create a window, okay, or a frame, we can say. Fine. So these particular classes that we are going to use uh, in the game. Okay, so let's see what functions or what classes that we are going to use for the game. Okay, so let's just discuss the styling of the project. So what we are going to have a window, something like this. Okay, we are going to have a window, something like this, and inside this game, inside this window, I'm going to have a container. Okay, inside this frame, I'm going to have a container, and inside this particular container, I'm going to write the logic of game, right? We need to develop all of these things that we discussed in the last video, right? The graphics of the game, the mechanics of the snake, the control of the snake, that is going to be discussed in the container. So what this container is called, it is called panel, or we can say content pane, right? So the class we basically use for this particular work, so for creating a panel, is jpanel. Okay, so we basically use jpanel inside Java Swing. So if I basically make a declaration for this particular class, then it is going to make a content pane. Okay, and to create this particular frame, then we need to make a frame. Okay, so this is called a frame, and the class that we use is jframe for this. Okay, so in this particular project, in this snake game, we are going to make two classes. Okay, so the first one is going to be snake game. So this is the main class, we can say. So this is the main class, or uh, the class that is going to contain the main function. Okay, so this will be behaving like a JFrame. Okay, so we are going to make it inherit the properties all of the JFrame. Okay, so what we are going to write is snake game extends the properties of JFrame. Okay, and inside this JFrame, I'm going to have a JPanel. Okay, so the second class I'm going to make is the game board, and inside this game board, I'm going to write all of the logic of the game. Correct. So this board class is going to behave like a JPanel. So it is going to inherit all of the properties of JPanel. Okay, and inside this particular board class, I'm going to write the logic of the game. Okay, so that is the styling of the game. Okay, so let's just create a new project inside IntelliJ. So if I close this particular project, let's create a new project here. So I'm going to call it Snake 2D Accio. Okay, let's call this project Snake 2D Accio. So we don't need to use any of the generators here. Okay, so make sure you are not selecting any of the generator here, and just select this new project. And inside this new project, just select the language to be Java, because we are going to make a project inside Java, right? Select the location, whatever location that you need to create this project. And build system should be intelligent because we don't need any of the packages that are contained inside Maven and Gradle, right? So this build system should be intelligent. And JDK, that is your choice. I'm using OpenJDK 18. So it's up to you that whatever JDK you want to select. Okay, I'm going to select OpenJDK 18. Okay, and when I click on create, it is going to create a new project, that is Snake 2D Accio. And inside this source folder, I'm having a main function. So let's just refactor this snake game to be, this main class to be snake game class. Okay, and let's create a new class that is going to be our board class. Okay, so this snake game class is going to inherit the properties of JFrame class. Okay, so this is the J class that is contained inside the package, right? So this JFrame class basically creates a frame, or we can say a window, and inside that window our application is going to be contained. Okay, and this particular board class is going to extend the properties of JPanel. Okay, so this is inheriting all of the properties of the JPanel. Okay, and in this video we are going to make a basic UI of the game. Okay, so also we will be able to initialize the game as well, right? So let's discuss what are going to be the components of our game. Okay, so what are the components of our game? Let's discuss. So components of snake game, right? What we have. The first one is going to be our board. Okay, inside that board I'm going to play the game, right? And what other component we have is the snake, right? And the last component is that we have is the app, right? And these components have their own properties. Okay, have their own properties. So we need to initialize these properties. We need in order to initialize the game, correct? We need to initialize these properties and we need to play with these properties in order to develop the game, right? So let's discuss what are going to be the properties of these components of the game, right? So the board, okay, let's discuss about the board. So if we discuss about the board, the board is something, it's going to look like a square, right? Square or rectangle, it's going to look like a box, right? It is going to have some height, right? It's going to have some height and it is going to have some width, right? So these are the two properties that we need to discuss first. So the height and the width. Okay, so inside this board I'm going to make a snake. Okay, so our snake is going to look something like a bunch of dots, right? So this is our snake and our apple is going to be something like this, right? So let's just see what are the properties of the snake. Okay, what are the properties of the snake? So you can see there are dots. Okay, so we can say there are some number of the dots, right? And we can see there must be some dot size. Okay, so there must be some dot size also, right? And for the apple we have only the apple size, right? Now suppose if I, okay, let's just write down these properties inside it. So it is going to have some number of dots, or we can say the size of the snake, right? This is going to be the size of the snake. And the second one is going to be our dot size, the particular dot size, what we are going to have, and simple apple size. So for simplicity, we are going to make both of these to be same, and we will call it dot size. Okay. Now, okay, let's see if we have this board. Okay, if we have this board, inside this, suppose if height is 400, okay, if height is 400 pixels and width is 400 pixels, right? If the height is 400 pixels and width is 400 pixels, how many dots can I have? How many number of dots can I have? Okay. Now, uh, if you think more clearly, it is going to be something like this, right? So total number of pixels, we can say total number of pixels is going to be something like 4 into 100, 400 into 400, right? And when I divide it, with 10 into 10, right? Our pixel is going to be look something like this. So we can say our board is 400 into 400, right? 400, 400, and our small box is going to be 10 into 10, right? So how many number of boxes I have? It's this 400 into 400 upon 10 into 10, right? So if I have height equals to 400, width equals to 400, then the maximum number of dots, max dots, is going to be this number. This is something like 40 into 40, that is 1600, correct? Okay, so we can think something like this as well, that in a row, how many dots can I have? That is 400 divided by 10, right? And in the height, how many dots can I have? 400 divided by 10, right? So 40 into 40, total number of dots equals to 1600, right? So that's all of the properties that we need to initialize the game. Okay. Also, there's one more thing. How we can do it. Okay. There's one more thing, that is the positions of the snake. Okay. So if we have a board, and inside this board, where is my snake? Okay, where the snake is going to be. Okay, located. So if my snake is something like this, okay, so let's say this is our head, right? And the rest of the dots are body. Okay, so what we are going to do in the Java Swing applications, the coordinates are something like this. Okay, starting from 0, in the x direction it is in the horizontal direction, right? So this is our x-axis and this is our y-axis. So y-axis is basically uh, in the reverse order of the normal coordinate axis, right? So this is our y-axis. It starts from 0 to x in the right and to y in the bottom direction, right? Now suppose now what we are going to do is, for this particular snake, we are going to make two arrays. The first one is going to be our x. The first one is going to store the x coordinates of all of the dots, right? And the y coordinates of the all of the dots. Okay. So if the snake size is 3, then we are going to have, okay, we are going to make an array of max size. Okay. So this is going to be our max dots, because the maximum size of the snake, that is going to be the max dots, right? So this is the maximum number of dots that we can have on the board, right? So this is the max dots we have. Okay. So we'll be creating an array of max dot. Okay. And inside this max dots, I'm also having a variable, right? I'm also having the property that is the size of the snake. Correct. That is the size of the snake. So I know that from to which number of dots I need to consider. Okay. To which index I need to consider the snake. Okay. Now, if we have this particular snake, we have 3 number of dots, right? So the size of the snake is 3, right? So we are going to consider 0, 1, 2. Okay, 0, 1, 2. We will not consider all of the boxes, but we have it if in case if the size of the snake gets increased. Okay. Right now we will be only considering 0, 1, and 2. Okay. And if we have this 0, 1, and 2. Okay. Now suppose if we start head, okay, if we draw the head with 50 pixels on the right and 50 pixels on the down. Okay, So this is our head position. Okay, our head is going to be the 0th index coordinate. Okay, so let's write 50 on the 0 and 50 on 0 here. Okay, now what will be the position, what will be the coordinates of the second dot? Okay, if you think clearly, it is going to be something like this. So if the head is 50 in the right direction and we have dot size equals to 10, right? Dot size equals to 10, then this is going to start at 60, correct? So my head was starting here, right? My head was starting here and it was till here, and the second dot is going to start with 60, right? And we can say it is uh, y pixels down. Okay, it is same pixels down as the head. Okay, so we can say the y coordinates are same, but the x coordinates are not same, right? Because the dot is basically towards the right. Okay, so it is not having any difference with the head in the y axis. Okay, so what will be the coordinates of the x and y axis will be, or what will the coordinates of the second dot will be? It is going to be 60 and 50. Okay, similarly, if I talk about the last dot, it is going to be 70 comma 50. Okay, now suppose if snake was something like this, suppose if the snake was something like this, then okay, it is in straight line. Okay, it is in straight line. Okay, if the snake was something like this, what will be the coordinates of the uh, what will be the coordinates of the y-axis? You should pause the video to think about it. Okay, what will the coordinates of the snake? So it is going to be, if we start from 1 0 1 2 and 0, sorry, 0 1 2, right? And suppose if the head is at 50 in the right and 50 pixels on the down, then what will be the coordinates of the second dot? You should pause the video and think about it on your own. Okay, so if we think about the axis, you can see the second dot is having the same x position, right? It is having the same x coordinate with the head, right? But it is not having the y coordinate say as same to the head, right? So you can see there is a difference of the dot size here, right? Difference of the dot size here. So whatever coordinate that is the head is having, okay, if it is having 50 comma 50, then if the second pixel is down to the head, okay, so it is going to have a difference in y axis. Okay, so it is going to have a difference in y coordinates. Okay, so it is going to be 60 and 50. Basically, y of any coordinate I, we can say, is equals to 50 plus, so this is the y of 0, right? Y of 0 plus, we can say, 10, or we can say the dot size into I, correct? Now if I talk about y of 0, it is going to be the it is going to be 50 plus 10 into 0, that is going to be 50, right? And if I talk about y equals to y of 1 equals to y of 0 plus 10 into 1, right? So that is going to be 50 plus 10 into 1 equals to 60, equals to 60, right? Similarly, in the case 1, we can say same for the x-axis, right? So we can say x of I is equals to x of co plus dot size into I. Okay, so if I want x coordinate for any index in the first case, okay, so this is for the case 1 and this is the case 2. Okay, if I check for the case 1 and case 2, so in the first case the x coordinates are going to be depending on the head like this. Okay, and the y coordinates in the first case is going to be equal to the y of 0. Correct? So this will be the case in the first case, right? This will be the coordinates in the first case, and in the second case this is our y coordinate, and our x coordinate is going to be something like this. Okay, it is going to be same as the head coordinates, right? Now let's take one more case. If there's a case something like this, dots are something like this, diagonally to the right and to the down. Okay, so what will be the coordinates of this? Okay, suppose if it is 50 pixels right and 50 pixels down, then it is going to be something like this. If the x coordinate of 0 is 50 and y coordinate of 0 is 50, then our this first index dot, right, this is the first index, this is the 0th index, then this is going to be something like this: x of 1 equals to 60 and y of 1 equals to 60. This is not possible in our case because snake will not move diagonally in our board, so we can just reject it. So there will be either in the there will be difference in either x coordinates or in y coordinates. Okay, so the dot will be something like this or something like this. So these are all the cases that we can have. Okay, fine. So that was all the theory about the logic. That was all the theory about the game initialization. Okay, so let's just initialize the game. Fine. Now what we need to do is, if we go to the snake game, okay, let's just first create an object of it. Just create an object of it. So initialize snake game. Okay, and inside the snake game, I'm going to create an object snake game class. Snake game equals to new snake game. Okay, and okay, fine. And inside this snake game class, I'm going to make a constructor here. Okay, and inside this constructor, I'm going to make an object of this particular board class. Okay, so I'm going to make an object board, and I'm going to declare it here. Okay, board equals to new board. Okay, and what we need to do is, because it is behaving like a JFrame, right? Because it is behaving like a JFrame, we are going to make it visible, right? We need to set its attributes like we did in the JFrame. Okay, so how we are going to do that? What we need to do is set visible to be true. Okay, set visible to be true. So this will set this particular JFrame to be visible. Okay, it will not be hidden anymore. Fine. And let's just initialize the dimensions of the board here. Okay, so how we are going to do that? Let's make a board constructor, and before this constructor, I'm going to make some dimensions here. So public, or we can say int b height. okay, equals to 400. Let's have it 400 pixels, and the width equals to 400. Okay, so this is our height and the width of this. And what we are going to do is, inside this board, I'm going to set the preferable size, set the preferred size, and inside this I'm going to create a new dimension, and inside this dimension I'm going to provide the height and width of the height and width of the board. Okay, so the width must be in the first, okay, and height must be the second parameter. Okay, and after that what we can do, let's have it color, sorry, let's have it a background color. Okay, and inside this background color I'm going to make a color dot black. Okay, let's have it black color, and let's go back to snake game. Let's add this board to the frame. What we need to do is add board. Okay, and let's see if it works fine or not. If I run this snake game class, let's see. Okay, if it is not working fine, let's see what is the problem here. Okay, what we need to do is back and set resizable to be false. Okay, and if I run it again, now you can see I'm having a board of 400 to 400 pixels, right? So this is our particular panel, and inside this particular panel is of size 400 into 400 pixels. Okay, so what do I mean by this pack and resizable? Basically, it packs the frame. Okay, it packs the frame. It packs the particular parent component to its children component. Okay, so when we added the board to the frame, and then we put the pack function, right, it will make the frame resize to the board's dimension. Okay, so you can see we have just resized it to the board's dimension. Okay, so the board's dimension were b width and b height, that was 400 and 400. So that's why in the snake game, in the snaking class, the frame was basically adjusted to the board size. So that was the use of this pack function. And when we use pack function, we need to make the set resizable to be false. Okay, so yeah, it should not be resizable to the use by the user. Okay, fine. When we do this, we have initialized the basic UI of the game. Okay, so we have a particular frame, and inside this frame I am having a board of color black. Okay, and inside this board class I'm going to initialize the snake, and I'm going to make the logic here, right? So that's all for this video. We will be continuing the basic building, basic UI in the next part, right? Hello everyone, I'm Priyansh Bhatnagar, and in this video we will be initializing the snake game. Okay, so what do I mean by initializing the snake game? We are going to basically initialize all of the properties of the game, of the components of the game. Okay, so what we are going to do is we are just going to initialize the properties of all of the components of the game. Okay, so how we are going to do that? We have already initialized the properties of board, right? That was the height and width of the board, right? Now we have to initialize the snake and the game part, right? How we have to do that? Let's do it, okay, in the logic part. So fine, what we need more is the int max dots, right? Max dots. That is the maximum size of the snake. Okay, so that is going to be 40 into 40. So that is going to be 1600, right? And sorry, int max dots. Beside max dots, we have the size of the dots. That is going to be the dot size. Let's have it 10. Okay. After that, we can have and number of dots of the snake. Okay, so we can have the snake size, or let's call it just dots. So dots equals to 3. Okay, so it will be initialized with these values. Okay, so also let's just initialize the position of the snake as we discussed here. Okay, so these were all of the properties of the snake and apple, right? And let's just create the coordinates of this. Okay, so how we are going to do that? Let's just initialize the coordinates of that. So let's make a function initialize game. Okay, so let's make a function that is public void init game. Okay, and inside this init game function, I'm going to initialize the coordinates of the string or coordinates of the game. Okay, so let's just initialize this dot here. Okay, I'm just doing it just for my sake. Okay, there's no reason behind it. Okay, fine. Let's just initialize these dots inside this init game. Okay, and inside this init game, I'm going to do what? I'm just going to initialize the coordinates of this snake. Okay, how we are going to do that? So we need an array, like we discussed. We need an array here. Array that we need two arrays here. So that is going to store the x and y coordinates of the snake, right? X and y coordinates of the string. So let's just initialize them. So let's have it int. Let's call it x equals to new int. Okay, and it is going to have a size of max dots, right? And y, it is also an array of int type, and it is going to have a size of max dots, correct? After that, I have to initialize the position. So initialize snake position. Okay, so how we are going to do that? We are going to make a loop and I equals to 0, I less than dot size, right? Dots and I plus plus. Okay, so for all of the dots that we have inside the snake, we are going to initialize the coordinates of it, right? So how do I want to initialize the game? Okay, so you can have it anyway. Okay, I'm just going to initialize it something like this. So I'm going to make a head at 50 comma 50. So this will be 50 comma 50, right? And I'm having all of the dots or all of the rest of the dots, right, in the right of him. Okay, in the right of the head. Okay, so this is going to be 60 comma 50. This is going to be 70 comma 50. This is going to be 80 comma 50, right? That's how I'm going to make it look like. So what do I need here? There's a difference in, there's only a difference in x coordinates, right? There's no difference in y coordinates. So what we discussed in the last video, you can see what we discussed in the last video, it is going to be something like this, right? So if I want the x coordinates of the index I, then it is going to be something like this, x of 0 plus dot size into I, right? So that was clear in the last video itself. So let's just do it. So x of I is going to be x of 0 plus 50, sorry, dot size to I, right? So x of 0 and y of 0 are going to be 50 comma 50. Okay, so x of 0 equals to 50 and y of 0 is going to be 50 also. Okay, and let's just make a loop from index 1. Okay, and y of I is going to be y of 0, right? So the y coordinates of the index I are going to be same as the y coordinates of the head. So we have initialized the x and y positions of the snake as well. We will be initializing this apple's position by randomizing it, but right now we are going to just initialize it with a constant value. Okay, so let's have it apple. Let's create x and y coordinates of the apple as well. So what we need to do is the int apple x, okay, and equals to, okay, and apple y, right? And let's initialize it to be 50. Sorry, not 50. Let's make it 150. Apple comma y equals to 150, right? So we have initialized this apple position. We will be randomizing it later on. Okay, so we will not randomize it right now. We have just initialized this position so that we can just draw the image in the next video, right? We can just draw the image of the apple at this particular position. Okay, so that's all about the initialize of the game. Okay, so we need to call this particular method inside the constructor of it, so that if the constructor is called, we have to just, this particular method will be triggered and the game will be initialized. Okay, so right now if I run anything, run my snake game class, nothing is going to appear because we have not just, we just did not draw anything, right? So we have just initialized the position of the snake, and what's left is we have to draw images of this snake and the apples uh, at these positions, right? Whatever we have initialized. In this video, we will be drawing the images and we will be drawing the components, okay, so of our game, that is the snake, right? The snake and the apple. Okay, so what we are going to do, in the first class we discussed that we are going to build all of these things, right? So in this basic video, we are going to just develop the graphics of the game. Okay, so in this, what I'm going to do, I'm going to, okay, I'm going to make some of the things in graphics. First of all, I need to get some images. Okay, get some images. What I need to draw. Okay, so I need to prepare some resources, what I need to draw at the particular location, right? So we have already initialized the position of snake and apple, right? But what we have to do now is draw the images at that positions. Okay, so what we need to do, first of all, we need to prepare the resources. So we need to get some images, what we need to draw, right? So we need to load these images in IntelliJ, right? So there's an object called, there's a class called image class. So we'll be using this image class to get the images from our desktop, okay, from our basically local system. Okay, so fine. And when we get these, when we prepare these resources, we need to draw these components, or we can say we need to paint these components. Okay, we need to paint these images at the particular location that we have specified. Okay, so we have already specified the locations of snake, right? But what we need to do is draw the images at that position. So let's do the first step. Okay, let's do the first step first. Okay, so what we need to do in our project, we need to create a new folder called resources. Okay, so let's go to src and click on new. Okay, and when I create here, okay, so let's go to file here and click on project structure. Okay, when I go to project structure, we need to go to the module section. And in the module section, I need to create a new directory inside the SRC folder. Okay, so I need to right click on the SRC folder, and I need to create a new folder called resources. Okay, so right now it will make this folder resources, but we don't need to do that. Okay, this should be a sources folder. Okay, so make sure this SRC folder must be a sources folder because it contains our classes, right? But inside the SRC folder, we need to create a new folder. Okay, so we need to create a new directory. So here we need to click a new directory and let's call it resources. Okay, and when I click on OK, inside this, a new directory gets created. Now this resources folder, this particular resources folder should be marked as resources folder. Okay, it should not be a sources folder, but a resources folder. Okay, and yeah, this SRC folder must be a sources folder because basically this sources folder is used to store the classes. Okay, used to store the Java classes. Okay, and what resources folder means? Basically the resources we need like images, right, audio files, right, GIFs, videos, what we need inside the application, right? So these are the resources folder. Inside this resources folder we need to get those images. Okay, so I have already provided these images inside our GitHub repository. You can find the GitHub repository link inside the description. Okay, so here I have provided the uh, drive link for that resources folder. Okay, so you can download the images of the snakes. Okay, so whatever images that we need inside this project, I have provided in the GitHub repository. Okay, so make sure you use these images, not any other image, because these particular images are 10 into 10 pixels. Okay, so we have already specified the size. We have already specified the size. Yeah, we have already specified the size of the dot, right? So that is equals to 10, right? If you remember in the last video. So that's why I have selected some few images that are of size 10 into 10 pixels. Okay, so make sure you select all of these images. Okay, after that, what we need to do, we need to click on apply and click on OK button. And inside this resources folder, I need to add some files. Okay, I need to add some files here. So okay, so what we need to do in this particular thing, wherever you have saved your project, okay, wherever you have saved your project, you need to uh, copy all of the images, whatever you have downloaded, uh, copy them, right? And after copying them, just right click on the resource folder and click on paste. Okay, and after that there will be some of the images there. Okay, so we need these three particular images. So the first one is going to be for the apple, and the second one is going to be for the body, and the head is going to be for the head of the snake. Okay, so what we need to do, okay, we have basically loaded these images inside our project directory, but what we need to do right now is to load these images inside this image class. Okay, so we need to create some image classes here. So images, here we need to create some image object. So I need an image for body, or we can say head and apple, right? Right, so we need to create these images. Now let's create a new method that load these images into these image objects. Okay, so load images. So basically we are going to load these images inside the resources folder, and we are basically going to load them into these objects. Okay, just from resources folder to image objects. Okay, fine, let's create a method public void, let's call this method load images. Okay, and inside this load images, what I need to do is first of all I need to create an image icon. Okay, there's a class called image icon, and inside this image icon I need to create a body icon. Okay, and basically when we load an image, okay, when we load an image from the resources folder, it should be an image icon, and then we get the image from the image icon, and then we put it to the image object. You will understand it. Let's just write it. So new image icon, and let's put the let's put the file name of that. Let's put the file path or that. So that is the src slash resources slash apple. Sorry, we are getting the icon for the body, right? So we need .png. Okay, so this is the image icon that we have loaded from the resources folder. Now what we need to do, whatever image object we have created, we need to store the image from the image icon. Okay, like this. So body icon dot get image. Okay, so basically when we stored the dot image into this body icon, image icon, we get the image from the body icon. Okay, and this particular image we are going to draw at the particular position. Okay, similarly let's do all of these things for head and apple as well. Okay, head, and here must be head. Okay, and similarly for the apple as well. Okay, so we have loaded all of the images to the this particular class board.java, right? Now what we need to do is the second step. So we need to perform the second step here. So right now we have just loaded all of the images to these image objects, and we are going to draw these image objects at the particular position that we have specified, right? So fine, let's create a new method for that. So draw images at particular position, or we can say the snakes and apple position. Okay, fine. Now what we need to do before that, before doing this step, you need to understand what paint component method is. So basically, as you already know, that our board class from the second video, if you remember, the board class is a JPanel, right? So it extends the properties of JPanel, right? So it is basically a content pane, right? Right. So what we need to do, there's a method inside this JPanel class that is the paint component. Okay. So we are going to use this particular method for custom painting. Okay, this method is basically used for custom painting. Okay, if we want to draw something customized, then we need to use this method, right? So we need to make some custom images, right? So we have already get some images and we need to draw at the particular position. So we need to use this particular method, that is paint component method. Okay, and inside this paint component method, we are going to draw these images. Okay, so fine. Uh, what paint component method is? So inside this paint component method, we provide a parameter. We provide a parameter of graphics object. Okay, of graphics object. So this particular graphics object, this G object, basically helps us to draw the images. Okay, so we basically use this particular object to draw the image. Okay, So what we need to do, let's basically overwrite the method. Okay, inside this override, I need to do public dot public void paint component. Inside this, I'm going to have a graphics object, right? Let's have it G. Fine. And after that, what we need to do, let's copy the original definition of paint component method, right? So we use the super keyword for that. And after that, let's make a separate method for drawing the images. Okay. So let's create a new method for, sorry, draw image. Okay. Here we need to use a new method. So let's call it public void do drawing. Let's call this method do drawing. Okay, fine. And let's call this do drawing method inside the paint component method. So let's specify the graphics object here as well, right? So we'll be using this graphics object to do the drawing. Okay, how do we use this particular graphics object? So what we need to do, so there's a method inside the graphics objects. This is something like this. So g dot draw image. Okay, so we basically use the draw image method for creating an image. Okay, now here we need to specify some of the parameters here. Okay, so first of all, we need to specify the image, that is the apple image, right? Then we need to specify the position of that image, so that is the apple x, if you remember, and apple y. So we need to specify the x and y coordinates of the image. Okay, and after that, what we need to do is we need to specify the observer. So the observer is going to be our board object. Okay, so this will be drawn in the J panel, so that's why we are just providing that this is the observer. Okay, so this particular board object that we have created is the observer, right? Similarly, we need to draw the images for the head and body, right? So how do we need to do that? Let's create a for loop for that. And I equals to 0, I less than dots, right? And I plus plus. Let's do this for all of the dots, right? And if I equals to 0, that means it is the head, right? I equals to 0 means that it is the head. And if it is the head, okay, dots was the capital, right? Fine. If I equals to 0, that means it is the head. So we need to draw the head image. So g dot draw image head, and what is the position? That is the x of 0 and y of 0. If you remember correctly, that we stored the x and y positions of all of the dots of the snake inside this particular array, right? So we need to use these arrays to draw the images, right? An observer will be this here also, right? Similarly, and if it is not the case, if it is not the head, then we need to draw the image of body. Okay. So body image at x of I, y of I, and the observer will be this. Okay, so this particular method basically draws the image at the particular positions. Okay, now if we have done all of the things, so what this is doing, basically in the last section, in the last video, we basically specify the positions of all of the dots, right? Now what we are going to do, we need to draw the images at these particular positions, like 50, like draw the image at this particular position 50, 50, and then draw another image at 60, 50, and then 70, 50, similarly like that, right? Fine. Let's see if it works fine or not. Let's go to snake game and run this file. So we basically didn't call the load images method. So here in the board constructor, we need to load the images. Okay, so these particular mistakes can happen. So make sure you uh, see all of the things, right? Fine. Now let's see if it works fine or not. Now you can see in this particular application, we have loaded the image. So you can see we have loaded the head image at the 50,50 and the dots image at 60,50 and 70,50 respectively, right? And our apple is basically drawn at the 150,150. Why these are drawn at these particular positions? So we have specified these positions in the last video, if you remember. So using the init game method, so we basically initialize the position of all of the things, right? So at these particular positions, we have just drawn the images. In this video, we'll be talking about how we can randomize the apple's position. Okay, so right now we have just fixed the position of the apple, right? If you go to the board class, you can see we have just initialized the position to 150, 150, right? Now what we want, we need to get the position randomized every time, okay? Every time we eat the food. So right now we are not just, we are not creating the eating food dynamics. We will be creating that in the dynamics of the snake, right? What we are going to do is right now just randomize the position, apple position whenever we create the application, okay, whenever we restart the application. Okay, let's create a method for randomizing the position for every time. Okay, so how we are going to do that? Right now we have a application, we have a board. Okay, now this particular board has a width of b width, right, and has a height of b height, right? So this particular b height is equals to 400, right? And this is also 400. We have specified this. Now let's discuss what can be the possible apples positions. Okay, so you can see on the board we can have 0, then after that we have some coordinates here, and till 400 here, right? We have till 400 here. Now what we want, we can have apple starting from here, right? We can have an apple starting from here. Now we know that apple size is going to be 10, right? The apple size is going to be 10, right? So we can have another apple at this, right? We can have another apple at this. Similarly, till what last coordinate? You should think this by pausing the video. And if you have think correctly, it is going to be 390. Why 390? Because it is going to start drawing the image from 390 coordinate. Okay, and it will create an apple here, and it will take 10 size. And if you choose 400, if you draw the image at 400, then it is going to draw something like this out of the board. Okay, so what we can have, width. What is the minimum value we can have? That is 0. And what is the maximum value that we can have? That is 390. Same goes for the height as well, because the height of the dots, height of the apple is also 10, right? So we can have dots till 390, and when we go to 390 y coordinate, it is going to create apple like here. And if we select the 400 coordinate, it is going to create an apple outside the board. Okay, so the minimum value of height can be 0, and the maximum value of height can be 390. Okay, if this is clear, we have one more thing to discuss. What we need to discuss is the apple's position. It's going to be a multiple of 10. Why it is going to be a multiple of 10? Okay, suppose if we basically if we create an apple at 53, right? If we create an apple at 53, okay, so what is going to happen when we are going to make the snake move, right? The snake is basically at right now 50, 50, right? The snake is at 50, 50 right now. Head is 50, 50. And when we make it move, how we are going to make it move? We are just going to push the dot to the another position, right? So if this is something like this, it is going to be something like this, right? It is going to be something like this if we move it one step, right? If we move it one step, this is going to be something like this, right? So it is going to be 40 comma 50, right? And then the next dot is going to be 50 comma 50, and then 60 comma 50, right? So the heads position is never going to be uh, other than a multiple of 10. Okay, it is never going to be other than multiple of 10, right? If it is 50 right now, then it is going to be 40 after one step, or 60 after one step, right? So you get the point. So we will never have the position of snake dots to be other than a multiple of 10, right now, right? So if we have apple at 53, right? If we have an apple at 53, and you can see that if we check that if the head collides with the apple, that is never going to happen. Okay, that is never going to happen. Why? Because apple is at 53, right? And the snake head is always going to be a multiple of 10, right? So it is never going to be a 50, 53, right? So this particular apple is never going to get eaten. Okay, that will create a hole in the game, right? So you get the point. We can have a minimum value of width and height to be 0, maximum to be 390, right? But these should be a multiple of 10, right? These should be a multiple of 10. That is important, right? Okay. So what values we can have? That is 0, 10, 20, and so on till 390, right? So we can have values till 390 here. Okay. So how we are going to randomize these? So there's a class inside Java that is math class. So we are going to use the random method of that uh, particular class. Okay. So what numbers we can have randomly? Okay. So if you think clearly, we basically have random numbers from 0, 1 to 39, and we basically multiply with them 10. Okay. So we basically have 10 common in all of them. So let's create random numbers from 0 to 39 and multiply with 10. That's how we can get the position of x and y, right? So what we're doing, we are basically getting the random numbers from 0 to 39. And if you multiply with the 10, it is going to be same like this, right? 0, 10, 20, so on till 390, right? So that's how we are going to randomize the uh, position of the apple. Okay, let's just implement this particular thing. How we are going to do that? Let's create a new method. Randomize apple position, and here let's create a new method, public void locate apple, right? And inside this locate apple, I'm going to have no parameters, right? We don't need any parameters. Right now we need to specify the apple's position, right? How we are going to do that? So fine, apple x. Okay, so the x coordinate of apple is going to be from 0 to 390. That is clear, right? And it is going to be a multiple of 10. So it is going to be something like this. We need to have an integer value, so we need to typecast it math.random. Okay, math.random into 39. Okay, so we need to do that. Basically math.random generate a random number from 0 to 1, right? It basically generates a random number from 0 to 1, and if you multiply with any number, right, if you multiply with any number, so it basically generates a random number from that set. Okay, so if you multiply with 39, it is going to give me random number from 0 to 39. Okay, you get the point. So we need to multiply this math.random into 39, and after typecasting this particular thing, because it is not a type of int, Okay, so we need to typecast it explicitly. And after getting this random number, we need to multiply with the dot size. Okay, so we have specified the dot size, that is 10, right? Similarly, we are just going to do this for the apple's y coordinate, right? And instead of uh, okay, instead of calling it here, let's just have it locate app. Okay, let's just get locate apple here, and let's see if it works fine or not. So now you can see the apple is basically drawn at the random position, right? So it is drawn at somewhere here. Let's try to run it again. Let's see where it gets drawn, right? So it has drawn here. Now let's again run it. So it has drawn here. So you get the point, right? We basically have randomized the apple's position, and we have discussed what is the logic behind that. Okay, so that's all for this video. We will be doing the rest of the project in the next video. Thank you. Hello everyone, I'm Pyash Bhatnagar, and in this video we will be talking about how timer class work and why do we need timer class in our project, and how we can use it to make our features. Okay, so basically our timer class, we are going to use this timer class to make the snake move. Okay, so this is going to make the snake move. Okay, not exactly. It is not going to exactly make the snake move, but yes, it basically directs when the snake gets to move. Okay, so what happens is we are going to create a timer object. Okay, we are going to create a timer object. Let's say timer. Okay, so what happens when we start the timer? Okay, when we start it, start from 0, then goes to 1, then go to 2, and then so on, right? So what happens is now if we have a board, okay, now what I want, after some of the time, I want this particular snake to move in particular direction it is moving, right? To whichever direction it is moving, I need to make it move. Okay, suppose after some time it is here. Okay, it is here. So how do I know this? How do I know that how this snake moves to this new location? Okay, when it goes to this new location. Okay, so this is basically directed by the timer object. Okay, so when the timer gets from 0 to 1, okay, whenever it gets incremented, it basically generates an action event. Okay, it generates an action event. So it is similar to an a listener class. Okay, so it generates an action event, and we are going to make our board an action listener which listens to this action event. Okay, which listens to this action event, and whenever this action event occurs, we need to make the snake move. Okay, so in this particular video, we are just going to talk about how timer class work, and how we are going to use it for the moving the snake. Okay, for the snake dynamics, how the snake is going to move, like that is for the second video. Okay, but that is for the next video. Okay, fine. So whenever that action event occurs, okay, whenever that action event occurs, our board, this is our board class, right? This is our board class, which is also going to behave as an action listener. Okay, as an action listener. Okay, so this particular board listens to this action event, and whenever this action event occurs, okay, I need to make the snake move. Okay, so this is how this timer object is going to help uh, to make the snake move, right? So whenever timer gets incremented, okay, whenever timers get incremented, it is going to generate an action event, and after action event is generated, this particular board listens to this action event, and after that, we need to make the snake, right? So fine. How do we implement a timer? Let's go to board initialization because we need this in the initial of the game, right? So let's create a timer here. Timer, time, fine. And here, how do we need to create it? Uh, Fine. In the init case, I need to create a timer equals to new timer. And inside this, I need to provide two parameters. The first one is the delay. Okay. The first one is the delay and the action listener. Okay. What are these? What is delay and what is this? So first of all, this is our action listener. Okay. So this particular board class is going to behave as an action listener. So let's implement an action. Implement action listener class. Okay. Action listener class. Okay. And if it implements an action listener class, so it is going to listen to this action event. Fine. And after that, what we need to do is timer dot start. Okay. Now let's just create a new variable delay. Okay. And delay. So delay is basically, let's have delay equals to 300. I will tell you what delay is. Okay. Fine. I think I have done. Okay. Now, fine. Whenever this time, now the timer has been started, and whenever this timer gets started, uh, whenever this timer gets incremented, it needs to generate an action event. Okay, it creates an action event. And how do we know that if an action event occurs, we need to do this? There's a method. There's a method called action performed method. Okay, action performed method. So we need to implement this action performed method to tell the compiler that whenever this action event occurs, we need to move this. Okay. Now what delay is? Okay. What delay is? So basically delay maps the timer. Okay. Timer to the actual time. Okay. It basically maps the timer to the actual time. Okay. When the timer will goes from 0 to 1. Okay. It is not fixed that it will go 0 to 1 after 1 second. That is not true. Okay, so we need to specify the delay. We need to specify the delay when the timer gets incremented. So if I specify delay equals to 300, that means after 300 milliseconds. Okay, so the unit of delay is milliseconds. So 300 milliseconds, that means 0.3 seconds. Okay, after 0.3 seconds, the timers get incremented. So every 0.3 seconds, the timer gets incremented. Okay, so it basically helps us to map the timer to the actual time. Okay, so fine. Now here, okay, whenever it generates an action event, we need to make a method that is going to handle that action event. Okay, so let's have it override public void action perform method. Inside this action perform, I'm going to have a parameter action event. According to the action event, it is going to take some operation. Okay, fine. Whenever this action event is generated, we need to perform the move function. Right. In this video, we are going to talk about how the snake is going to move, or we can say how the snake dynamics are going to implement it. Okay. So in the last video, we talked about how timer works, how timer class works. So whenever timer gets incremented, we need to perform a move operation. So let's just understand how the snake is going to move. Okay. So right now we have a snake. We have a particular snake. The first one we head is at 50, 50, right? The second one is at 60, 50. The last one is at 70, 50. Correct? Now, uh, there are four possibilities. Okay, so there are four possibilities. Let's have more size. Okay, so it is going to be at 80, 50 and 90, 50. Fine. If the snake is of 5 sides, right? And there are four possibilities. The first one is if it is going in the left direction, up direction, right direction, or down direction. So let's assume that it is moving in the left direction. Okay. Now, what is going to happen after the timer gets incremented? If it is goes from t to t plus 1. Okay. Whenever it gets incremented, it is going to move. How it is going to move? this particular dot is going to appear somewhere here, right? So this head goes to this, right? And this particular dot goes to here, right? And this particular dot goes to here, right? And this particular dot goes to here, and this here, right? And there's nothing here, right? So the new coordinates of snake becomes something like this: 40 comma 50, right? So why 40 comma 50? Because it is right now it is 50 comma 50, and the dot size is 10. So basically 50 minus 10 equals to 40. Okay, so basically the dots get shifted, okay, by its dot size. 40 comma 50, 50 comma 50, 60 comma 50, right? 70 comma 50, 80 comma 50, right? Now if I want to generalize, if this particular snake is moving in the left direction, you can see if it is moving in the next direction, we can say that x coordinates of all of the dots are just decrementing by its dot size, right? So you can see if we have the initial x position of all of them, that was something like this, right? 50, 60, 70, 80, 90, right? And x final is something like this: 40, 50, 60, 70, and 80, right? So you can say that all of the x coordinates are just decremented by its dot size, right? So fine, this is true to this some extent. Okay, let's see. And if it is in the up direction, how it is going to change? So if it is here, right, how it is going to change? It is going to have difference in the upward direction, right? Or we can say the bi-direction, right? So if we have board and x goes from 0 to 400 here and 0 to 400 here, right? We can say if we going in the downward direction, we can say y is increasing, right? If we are going in the upward direction, we can say y is decreasing, right? And if we are going in the left direction, we can say x is decreasing. If we are going in the right direction, then we can say x is increasing, right? This is clear. Fine. So what if I want to generalize things? If uh, if we are going in the left direction, we can say that x of I is going to become uh, x of I minus dot size. Is this true? If you think clearly, or take your time, pause the video. But yes, after giving it a thought, just check that if it is true or not. Okay, fine. Uh, so this is completely not true. Okay, so this is not going to do that for all of the dots. Okay, why? Because suppose if the snake is moving in the left direction. Okay, suppose if the snake is moving in the right direction. Now the snake goes to, sorry, sir. Suppose we have snake something like this, right? We can have at a particular point of time, we can have a snake something like that, right? We are moving in the left direction. So now, if it is moving in the left direction, right? If it is moving in the left direction, what if we do same as we did here? Okay, like we decrement all of the coordinates by 10. Okay, what it is going to look like? It is going to look like something like this. You get it? What has happened here? All of the dots shifted by its x coordinate, but that shouldn't happen, right? This is not how the snake moves, right? This is not how the snake moves. Okay, so what's the catch here? The head, only the head goes to its particular position. Okay, only the x coordinate of the head is decremented by 10. Okay, rest of them follows its previous dot position, right? So it is going to look like something this. right? So how this happens? We basically do this particular thing for only the first dot, right? Minus dot size if it is in the left direction, right? But for the rest of the dots, what we are going to do? X of I is equals to x of I minus 1, right? That's how we are going to make the snake move properly. Okay, so we don't have to decrease all of the x coordinates accordingly to the direction, right? Or for all of the dots, we just need to change the direction of x coordinate. Okay, we just need to change the coordinates of x coordinate, head, right? We just need to change the coordinates of head. Okay, and rest of the dots gets the position of its previous dot. Okay, so that's the logic behind the move function. Let's just implement this. Okay, fine. Now if we go here, what we need to do, let's make a new function, make snake move. So public void move, right? And this particular move function should be called when the timer gets implemented, right? So if we call this particular move function here, whenever the action event is generated, this move function will be called. Right? Now how it is going to move? First of all of the previous dot, okay, all of the previous dot gets this position, right? So how we're going to do that? I of I equals to 1, I less than dots, sorry, dots, and I plus plus. Okay, fine. Now here's the catch. Here's one more catch. What we need to understand. Fine. The loop must go from the last dot. Okay, it should not go from this dot. Fine. Why it should not go from this dot? Because if the snake is moving in this direction, okay, first of all, what we need to do is uh, we need to update this last dot position to its previous dot. Okay, so this particular dot will be here, right? And this particular dot will be here. This particular dot will be here. This particular dot will be here. Then only we have to change the direction of head. Okay, so it's more algorithmically possible, right? Right. So these particular things, these particular dots have to uh, go to its previous dot, right? And then after that, the position of head is updated, right? Why is it so? Because if we update the first dot uh, early, then it is going to be something like this, right? If we have updated this particular dot here, and when we want to update it to this, now this particular dot has gone to this, right? So its x coordinate has been updated, right? X coordinated has been updated. Earlier it was 50, now it is 40, right? And when we want to update the x of 2, right? We want to same as x of 1, right? But right now it has updated, so it should not be at 40, right? It should be at its as it previous position, right? It should be at its previous position, right? It should be at 50, right? So that's why we need to start from the last one. Okay, now we need to change the parameters here. I equals to dots minus 1. The last dot is dots minus 1, right? Dots minus 1, I greater than equals to 0, I minus minus. And after that, what we need to do is x of z minus 1 with x of I equals to x of I minus 1, right? After that, y of I equals to y of I minus 1, right? And now, according to the direction, we need to update the positions of the head, right? Now, if we are going in the left direction, so first of all, we need to make 4 Boolean variables that in which direction the snake is moving. Okay, so bool left direction. If left direction is true, If the left direction is true, then it is moving in the left direction. So suppose it is moving in the left direction first, okay, and rest of them are false. Right? Boolean up direction false. Boolean down direction equals false, right? And now we need to change the position of the head according to the direction. Okay, so now if left direction is 2, then we need to update the x. We need to decrement it, right? So x of 0 minus equals to dot size, right? Similarly, if right direction is 2, okay, only one of them is going to be true, fine, because the snake will not go diagonally, right? Now, if right direction is 2, then the x is going to get increased, right? With what? With its dot size. So x of 0 plus equals to dot size. Now, if up direction is true, then what we need to do? We need to decrease the y coordinate of that, right? So y of 0 minus equals to dot size. And after that, if down direction is true, then we need to do y of 0 plus equals to dot size, right? So this is how our snake is going to move, fine. Now, if there are no errors, okay, fine, let's see if it works fine or not. Let's go to snake game class and let's see if it works or not. So basically what we are missing here is when we update the position of the snake, right, we need to redraw all of the drawings, right? We need to do the drawing again, right? So now the snake position has been updated according to the move function, but we have not repainted it, okay? So what we need to do, there's a function here. We just need to repaint all of it, okay, according to the function. So what we need to do, we just need to call the repaint function. If we go to snake game and run the application, now it is moved, right? And if we initialize the snake with some more here, or if we initialize it from 250, okay, you can see more how it's going to move. Right? So it is moving in the left direction, right? Fine. In this particular video, we are going to implement the controls of the snake by the key button. Okay. Also, we are going to make the snake eat food. Okay. Now, the first step is going to implement the controls. Okay. Implement controls by the key button, and the second step is going to be the food eating, right? Fine. How do we implement controls? We are going to use a class called key adapter class. Okay. So we're going to use a class, and we are going to extend this properties and make it work like and customize it. Okay. We are going to customize the key adapter class. Okay. Fine. Let's just implement that. That's not a big deal here. Fine. What we need to do, implement controls. Okay, so what we need to do here is implement a class. Let's have it private class t adapter. Let's call it t adapter, and we need to extend the properties of key adapter class. Fine. And inside this class, I'm going to override a method. I'm going to override a method. So that's how we do customization, right? We need override method. we override the parents method, parents class methods, right? So how do we do that? We just put the keyword @override, right? So there's a method inside key adapter class called key pressed, right? So we are going to call this method key pressed. So basically it generates a key event, right? In whenever we click on some button, so there are some arrow keys, right? There are some arrow keys, right? And there are some other keys on the keyboard. So whenever we click on any of the buttons, it generates a key event, okay? Like an action event, right? Key event. Okay? And this particular key, according to this particular key event, we need to perform some action. So if it is the left key button, we need to make it in the left direction, right? If it is down, then down, right? And so on. So that's how we are going to do the key event. After that, I need to get the key code. So in key, what key we have pressed. So how do we going to get that? Key event dot get key code. Okay. Now, if that key code is equals to key adapter class dot, there's a constant inside a key adapter class, that is vk. Sorry, there's a there's a constant in key event class, not key adapter class. Sorry, there's a constant in key event class and key event dot vk up. That means we have clicked on up direction. Let's implement the left first. We have clicked on left we have clicked on left button, right? Now there's one more thing. If we have clicked on left direction, left button, then we should need to move the snake in the left direction, correct? Now there's one more check, that if the snake is moving in the left direction, right? If the snake is moving in the left direction, sorry, if the snake is moving in the right direction, okay? And now when we click on left button, it is going to be something like this, right? And the head gets overlapped with the first dot, right? So this should be an invalid move. So whenever we are getting a left event, so it should be checked that the snake is not moving in the right direction, right? So right direction should be false here, right? Fine. And if that is true, then what we need to do is left direction should be true and all of the other directions should be false. Now right direction is already false, that's why we have jumped into the if block. So rest of the directions must be false. Okay, so up direction must be false, down direction must be false. Fine. Similarly, we need to do this for all of the events. Now if we click on the right button, the snake should not be moving in the left direction. You should know that. And if we have clicked the right button, then instead of left direction, the right direction must be true, correct? And up direction, down direction must be false. Left direction is already false, right? And if we click on up button, then the bottom direction must be false, right? We should not be in the down direction. And if that is true, then instead of right direction, the right direction must be false and up direction must be true, correct? Because we have clicked on up button, and left direction must be false, right? It's only up direction must be true and rest of the direction must be false if we have clicked on up button, fine? And similarly for the down direction, it should not be moving in the up direction, correct? And instead of up direction, we need to specify the right direction here and make it false. Down direction should be true and left direction must be false. Okay, so now we have specified all of the controls, how the snake is going to move if we click on certain button, right? I don't think we we need to implement any more controls, right? Now what we need to do, we need to create an object of this tAdapter class here in the board constructor. Okay, what we need to do is tAdapter equals to tAdapter equals to new tAdapter, correct? And this particular tAdapter must be added as a key listener. So add key listener to the board. Okay, so add key listener tAdapter. Okay, and to make this work, we need to add one more control, that is set focusable. So we need to make this particular board to be focusable. Okay, that is also needed here. Let's see if it works or not. Right? If I'm clicking on left button, it is going in the left direction. If I'm clicking on up button, then it is going on up direction. If I'm clicking on right button, then it is going in the right direction. And if I click on down the button, then it is going to down direction, right? And the snake is also moving fine, correct? Yep, it is bending perfectly. Now the only thing left is we should make this eat food, right? We should make this eat food. Right now it is just passing through it. Why it is passing through it? Because yeah, we have not added the check for the eating food, right? Okay, I just get lost in the playing game, right? Also, we have not added the collision checks with the border and the body, right? So that's also we need to implement in the next video. Okay, so let's just implement the check for the collision with the apple. Okay, so that we can make it eat food. Okay, how we're going to do that? Let's make so that's very easy. Make snake eat food. And how we're going to do that? Let's make a function public void, and let's call it check apple, because we are going to check the collision with the apple. Okay, now what we need to check in this particular thing, that is very simple. If our snake's head, this is our head, right? If our snake's head position is equals to the apple, right? If this particular head's position is equals to the apple's position, then we can say that snake has eaten the food, right? So that's how we are going to check that if the snake has eaten the food or not. So if that is very easy, right? If x apple's x position is equals to head's x position, and apple's y position is equals to y position of head, right? Then what we are going to do? First of all, dots must be increased. The size of the snake must be increased. Correct? That is true. Second thing, the apple position must be randomized again. Fine. So these are the two things that we need to implement. Correct? Now let's just see if it works fine or not. Right, let's go to the apple. Okay, it is not working right now. Let's see what is the problem. Okay, we have not checked the apple again and again. Okay, so we need to call this particular method at the timer's incrementation. Okay, so whenever timer gets incremented, we need to check every time that if there's a collision with the apple or not, right? So we should call the method before checking, right? Let's just check that if it's working fine or not. Fine, the snake size gets increased by 1 and the apple gets randomized, right? I think it is working fine for me. Why the snake is moving so slow? Because of delay, right? It is of because of delay. If we decrease the delay, then the timer gets incremented sooner. Okay. Now, if we decrease the delay, the snake gets more fast. Now the snake speed gets doubled, right? I think this particular speed suits better. Fine. So that delay variable basically controls the speed of the snake. Okay, fine. So that's all about the controls of the snake. In the next video, we are going to implement the checks for the border and body collision. Okay. Hello everyone, I'm Priyansh Bhatnagar, and in this video we are going to implement the checks for the collision with the border and the body. Or basically we are going to make the snake's game over. Okay, fine. So okay, right now what we need to implement is the border collision, right? And the second is going to be the body collision. Fine. If we have okay, how we are going to check that? Now suppose the snake gets collided with the left border. Okay, how what happens if it collides with the left border? Its position, it's going to be something like this. Correct? Position is going to be something like this when it gets collided with the border. Fine. Now 0 400. Okay. Now so we can say that if it collides with the left border, it's the x coordinate of the head. The x coordinate of the head becomes negative, right? We can say this is the x coordinate and this is the y coordinate, right? So that is true. If the snake get collided with the border, then the x coordinate becomes less than 0. Yes, so if x becomes negative, that means the snake has collided with the left border. Now, how do we check for the right border? If snake gets collided with right border, then obviously it is going to be greater than the b width, right? The specified width on the board. Okay. Similarly, if it collides with the up border, then obviously the y becomes negative, correct? And if it collides with the down border, then obviously the y becomes greater than p of height. Okay. So checking the collision with the border is easy. Okay. How do we check the collision with the body? Okay. How do we check the collision with the body? So what happens is, first of all, we have some particular snake size. Let's have 6 size. Okay. Now snake moves here and collides with its body. Okay. So how it is going to look like, right? It is going to look something like this. Okay. So there must be some minimum size. Okay. There must be some minimum size to have a collision with body, right? What is that? That is the 4, right? It should be a 4 size to have a collision with its own body, or even more than 4, right? Fine. So the size of the snake must be more than 4 to have a collision with its own body. Okay. Now, how do you check that if there's a collision with its own body? That is simple. We need to make a loop. Okay. We need to make a loop and check that if x coordinate of uh, if x and y coordinates of head is equal to any of the dots, right? If it is equal to any of the dots, that means that collision has been occurred with its own body. Okay, because if at some coordinate, if we have two dots, right? If we have two dots, that means the first one is our head and the first one is the part of its own body. That means there's a collision with its own body. Correct? So that's when we need to make the game over. How do we make the game over? For that, we are going to create a new variable called in-game. So in-game variable basically tells us that if we are in the game or not. Okay, so this is going to be a Boolean variable, right? So whenever these particular collisions happen, we need to make this particular variable false. Okay, and the game gets over. Fine. So I think the logic is, I think you're getting the logic how it works. Okay, so let's just implement it. Let's go to the board class, and here let's create a function. For check collisions with border and body. Okay, so let's call it public void check collision. Okay, and in this, first of all, check the collision with its own body. How we are going to do that? For int I equals to 1, I less than dots, I plus plus. You need to check that if any of the dot has the same coordinate with its head, right? So first of all, this I must be greater than 4. It should have a minimum size, right? And and the x coordinate of head is equals to x coordinate of I, and then y coordinate of 0 head is equals to y coordinate of that dot. Okay, then we can say that in-game variable is false. Okay, so let's create an in-game variable, boolean in-game equals to true. So in initial it is going to be true, right? In the starting we are going to start the game, right? Fine. And if the collision happens, we need to make the in-game false. Correct? So this is the collision with the body. And after that, collision with border. How we are going to check that? If x of head, right? If x coordinate of head is less than 0, that means it has collided with the left border. If you remember here, right? So in game here must become false. If x of 0 is greater than the height, then also it should become false, right? Should be equal to, right? If the y of 0 is less than 0, that means it has collided with the upper border. Right? Now if y of 0 is greater than equal to b, sorry, x coordinate must be compared with the width, not height. That's a mistake. B height. Okay, so y must be compared with the height, and if it is greater than the height, then the in-game must be false. Okay, so that's all with the check collision method. Where should we call this particular method? So it should be called every time when the timer gets incremented. Okay, fine. All of these things, all of these things must be done if in-game is true, correct? Then only we should do them, right now. Then we should uh, basically call all of these methods, right? If in-game variable is true, that means we are in the game. Then only we need to check the apple, check collision, and fine. I think that is simple. Okay. There's one more thing what we need to do. Uh, Okay, fine. In the drawing function, okay, all of these things must be done if we are in the game. Okay, fine. Otherwise, we need to stop the timer. Timer must be stopped. Correct? Let's check that if it works fine or not. Let's make it size more to have a collision with its own body. Okay, I think it will work if we make a collision. Let's make it more size. Fine. Let's make a collision with its own body. Fine. So basically timer gets stopped. Right now it is empty. We will generate a game over message for that. Okay. Now let's check the collision with the border. Okay, it is also working fine. So whenever it gets equal to the border values, then the game is going to get over. In this video, we will talk about how we can implement game over message, right? How we can display game over message and score after the game gets over. Okay, so let's discuss about how we want it. Okay, let's discuss the design. If we have our particular application here, it should be at the game over message should be here, right, in the center, right, and below this there must be some score, right? There must be some score defined, right? Fine. It should be in the middle. It should be in the middle of the screen, right? And this particular height must be okay. Let's have it something like this. Fine. If this is the h by 2, if this is particular h, right? This is h by 2, then the game over message must be displayed at h by 4, and this particular score must be displayed at 3h by 4. Okay, so that we have particular space between game over message and score. Okay, and okay, where should we start the game over message, that we should discuss. Okay, so the height is simple, that is h by 4 and 3h by 4. But yeah, where should we start the in the x coordinate? That must be dependent upon the width of the message, right? That must be dependent on the width of the message, because the height is negligible. Height is only 14 pixels. We are going to make a 14 pixel message. Okay, so if you if I make font size equals to 14, that means I have a height of 14 pixels. Okay, but fine, if we okay, for this particular x coordinate, we need to it depends upon the length of the message. Okay, now how we are going to get the x coordinate? First of all, we need to specify the font. Okay, the font we have Helvetica. Okay, we need to create a Helvetica family font. You can choose anything, Times New Roman, Arial, and so on. Fine. And what we want of bold size. Fine. And what we want of size is 14. Correct. So that's how we are going to make a font. According to this font, we are going to choose the x coordinate, that where we should start printing the game over message. Okay, that should how we should display it. Okay, so let's just implement it and I will make you understand. Okay, first of all, okay, now what we need to do is make a new function, public void game over. So because we need to do the drawing here, also we need to draw a message here, we need a graphics object here as well. Fine, and we need to draw a string instead of an image here. Okay, so first of all, what message should we print is the game over message, correct, and the score. So let's calculate the score first. That is going to be what? dots, that is going to depends on the number of dots, right? Dots minus 3. Why 3? Why it should be 3? Because the initial dots was 3, right? So whenever it eats the food, the dots gets increased, right? So in the initial, the score is always 0, right? So when the dots become 4, the score becomes 100. Then the dot becomes 5, the score becomes 200. The dot becomes 6, the score becomes 300. You're understanding, right? So when the dots is 3, I want the score to be 0. Okay. When the dots gets increased to 4, the score becomes 100. Okay. When the dots become 5, I want the score to be 200. When the dot becomes 6, I want the score to be 300. You get the point, right? So what we need is dots minus 3 into 100. Okay, this is the score, right? If we have dots equals to 7, then 7 minus 3, that is 4 into 100, yani 400. Fine. Now what we need to do here, where is our function? Display game over message star 100. Okay, now we need to develop a score message. So score message is going to be something like this: score equals to plus, okay, integer. So we need an integer class use toString function because we need to make this particular string. We need this particular integer to string. Okay. Fine. I think it should work. And okay. Fine. Now let's make a font. How the font is going to look like. So let's make it small font. Okay, let's call it small font and create a new font object. And inside this, I'm going to specify what are the attributes. So Helvetic I want it to be bold. So there's a constant inside the font class, that is bold. Okay, and the size must be 14 pixels. Okay, now what we are going to do, we are going to get the metrics of font. Now why we are getting the font metrics? Small dot get font metrics. Okay, we don't need small here. Small. Okay. Fine. Now what this font metrics does, it basically gets the size of it. Okay, it basically gets the size of it. Now suppose it basically gets me the width of the message and height of the message. Okay, now suppose if I make a method, if I make a message, okay, if I make a message game over, now what font metrics will do me, it basically writes this particular game over in this particular font, right? And it basically gets me the height and width of that message if we basically display this message in particular font. Okay, so that's what font metrics object does. That is important because we need the x coordinate here. Okay, how we are going to do that? That is I'm going to tell you. Okay, so what we need to do is g dot set color. First of all, we need to set the color. If the background is black, then I need white color font. Right? You can choose anything if you want. Fine. G set font. Font should be small font. Okay, whatever font we have specified. Okay. G draw string. Okay, first of all, the first string should be drawn here. That is the game over message. Okay, where it should be drawn. What is the message? That is the first message, game over message, right? And the x and y coordinates of that. First of all, the y coordinates must be be height by 4. Okay, that is clear enough. We are just implemented. We are just specifying the h by 4 direction, h by 4 y coordinate to the game over message. Fine. Now for the x coordinate. Okay, this is tricky. If we have a board here, okay, if we have a board here, and I want the game over message in the center. Okay, I want the game over message in the center. Now this is the complete bay width, right? Correct. And we have some length in the string. Let's call it L. Okay, let's have it W and this to be L. Okay, so this must be our starting point. Okay, you can understand that this must be our starting point of the message. So we need this value, right? We need this value. If we want this particular message to be in the center, that means that here also we are having a gap of x here, right? We are having a gap of x here. Correct now? So now we can say x plus L plus x. X plus L plus x is equals to W, complete width, right? And we need to find the x coordinate. What is this? 2x plus L equals to W, correct? Now 2x equals to W minus L, correct? X equals to W minus L by 2. Okay, so this is basically the bay width, right? Minus, we are going to use the matrix and get the width of the string. Okay, get the width of the message. Okay, and after that we are going to divide it by 2. So that is the x coordinate of the game over message. I think you understand that. Fine. So what we're going to do, the width minus font matrix dot string width of message. Fine. And when we subtract it, we need to divide it by 2. Similarly, we need to do this for the score message as well. Correct now? Okay, and here the height, the y coordinate must be 3h by 4, right? So 3 into b height by 4. Okay, so this is all about the game over message. We should call this method to get the results. So where should we call it? Okay, so in the doDrawing function, when the in-game gets false, the timer gets stopped, right? So when we are doing the timer gets stopped, we need to make a game over. We need to call the game over method here. So game over, and here we need to pass the graphics object. Let's see if it works fine or not. Okay, let's eat some food first so that we can check the score as well, right? Okay, let's go live to the border. Fine. So we have specified a game over message and we have got the score as well. So that's all. That's all of the features in the game. Okay, so we have implemented all of the features in the game, whatever we have discussed in the starting of the video. Okay, so if you want to develop some more features in this game, so here are some ideas. First of all, you can add a game menu. Okay, so right now the game gets started. The game gets started whenever we execute the operation, right? So you can make a menu before that, and before making a menu, right, when we click on start button, you can make the in-game variable to be true. Okay, the second idea is you can have a restart button at the end. Okay, so when the game gets over, if you click on restart button, then the game gets started again. Okay, you can have a high score value also. Okay, so highest score, what is your highest score? And yeah, that's all for this particular minor project. Thank you for being with me, and that's all for this video. Thank you.